I'm Yael, and I'm a front-end developer at Wix in the past 3 years. I work with JavaScript, and I love talking about it and about its new features. I see it super exciting how JavaScript has evolved throughout the years, especially when it comes to async code. So about today's topic. A few months ago, I noticed this feature, async iteration, was already in stage 3. That's huge. It means it could be in the next ECMAScript version. And more than that, it was announced to be part of ES 2018 just a month ago. It's so new and fresh that there's still not enough discussion around it yet. So that's exactly why I chose to focus on it today. So today's topic is async iteration. So we'll see what they are, what we can do with them. We'll see a real-life example. And if you're asking yourself, can you use it today already, then yes, you can. And I'll show you exactly how. But before we begin, I want to do a quick refresher. I want to quickly go over some basics that I'm sure you're already familiar with. I'm sure you're familiar with these 3 features. The first one is async functions, also known as async-await. They came in ECMAScript 2017, and about generators and iterators. I want you just to have them fresh in your minds. So you probably remember this kind of code. This was the way we had to deal with async functions at the beginning. Whenever we wanted to call something that was async, we had to pass a callback function. The convention was to get the error as the first argument, and then the result. You get the result. But if you want to call multiple async functions, then you had to start putting them one inside the other, and you get a callback hell. So this is really messy. You have to also handle the error for every single callback. So this is really bad. But fortunately, promises came, and it made our code so neat. You can catch the error once for the whole chain. You can call multiple async functions by chaining them, and we don't have to implement callbacks and stuff like that. So we thought it's heaven. But what happens if we need to save a reference from one async function just to do a final calculation with another async function? We have to start indenting them one inside of the other. So again, we have indentation again. That's not fun. We need a better solution. So also with promise chaining, we have to handle our errors that come from the promises with a dot catch. But our synchronous errors are caught with a try and catch block. So we end up having we have to handle our errors in 2 places in 2 different ways, and that's really not fun at all. You can agree with me now that there must be a better solution. So this is an async function, and it actually solves all those problems. An async function is a function that has the keyword async before it, and you can use the await keyword inside of it. And the await keyword, it will wait. You can put it before your promise, and that will wait for the promise to be resolved, and it will return the resolved value. So an async function returns a promise. So the function itself returns a promise. Foo returns a promise, but it's not blocking the code outside of it. So this function doesn't wait for foo, does not wait for foo. But what's inside of the function after that waits for the resolution. So it makes our code look synchronous, but actually still asynchronous. we don't have to handle the then and stuff like that, so it makes our code really readable. It's like English. Also, with async functions, we are able to, if a promise that we are waiting on rejects, then the error is caught inside of the catch block. So we can handle both our synchronous errors and our asynchronous errors inside the same code with the try and catch. So that's neat. We can handle all of our errors just in one place. In what other situations can this help us? For example, if we have a synchronous condition and we want to ask another condition from an async resource, like ask someone from the network to give us an answer for something. It returns a Boolean, for example. So we need to handle a whole function just to get the resolved value and check the resolved value and then put our code inside it. And again, it's really indented. It's not easy to maintain. And async functions solve that because when you write an await promise, it's actually another expression. You can put it inside an if. You can also put it inside a value of an object literal. It's really easy to deal with. So you will see that async functions make our code really readable. It's like reading English, easy to maintain. All of our error handling is in one place. So I say that whenever you can, just use async-await instead of chaining promises. But still, with all those good stuff I said about async-await, there's something we need to be careful with. Like here, we call two promises. The first promise we await on, it's called getStuff, and then we await on getStuff unrelated, but that only starts after getStart's resolved. So we wait for the whole first promise, and then we wait for the second promise. And those two functions are unrelated. So we should call them concurrently. Like, why not save time? So this is bad practice. Try not to not wait for stuff when you can run them concurrently. So this is the good way to do that. Whenever you want to run two promises concurrently and wait for their resolution, you should await with promise all. And if one of them rejects, then the whole thing is rejected, which is actually what we want because we have no value for only a single resolution. Does somebody know what's wrong with this one, with this example? What's bad practice here? Well,
it doesn't really await.
So the two promises run concurrently because when a promise, when you create a promise, it already starts. It doesn't matter when you await on the promise. So they run concurrently, but you await on them sequentially. Now, what happens if, let's say, both of them reject? So if both of them reject, then we get to the await A, and then it rejects. So foo will reject. We will never get to the function to the point where we are awaiting on B. So we're not handling, we will never handle B. So we'll get an unhandled rejection. And you'll get a console error, and that's not good. Also, let's say if A took 5 seconds to be resolved and B took like 1 second to be rejected, then again, not only we're wasting time waiting for A, when actually we could just throw the whole thing. We will get an unhandled rejection for B, which will be handled asynchronously after after A was resolved. We will get to the point where we handle B. So also both cases are bad, and there are also more. So whenever you can, whenever you need to run them concurrently, just await in them with await promise all. That's a good way to do it. OK, so we talked about async functions. They're good for you. They make our code readable. Use them whenever you can. Now, in E6, iterators came, and iterables are objects that have it's a protocol to produce sequences of values. They can be either finite or infinite. So there are a few built-in iterables in JavaScript. For example, arrays for the items. You can iterate over the items, and maps and set over the entries, and strings also with over the characters. So every iterable has an iterator object inside of them. They can return an iterator object. So they return an iterator object that, that gets the next value every iteration. So there's a cool new syntax that came in ESX that consumes those iterators objects. And what it does, it takes the iterator object, and it gets the next value and puts it inside the result and checks if the sequence is done. If it's done, then it ends the loop. So how can we create our own iterables? It's really easy, actually. We only need to implement a interface. And yeah, I know there are no interfaces in JavaScript, but it's like just a convention. So this is the Iterator iterable interface. This is a way to produce a sequence of values. So an iterable has a method with the key of symbol iterator. And this is just another constant. And it returns an iterator. And the iterator has a method next that returns the next item. It returns an iterator object, iterator result. And the iterator result has a value and a done indicating if we already produced the last item in the sequence. So Iterator also has two more optional methods, throw and return, but I'm not gonna get into them because it's not really relevant now. But I'll just say that return is the method that can handle the cleaning after if you need to clean after you. Like if we break outside of the loop and we want to clean some resources or something like that, then return is called. So this is a iterable I created. It's a sequence of square numbers, and we say it's iterable because it has a method with a key of symbol iterator, and it returns an iterator. And the iterator has a method next, and the method next returns an iterator result. So it's pretty simple. So there are other ways to create iterables. Generators. Generator is also a way to create an iterable. A generator function is a function that has an asterisk after the function keyword, and you can yield values, and actually there will be the next values you produce. So a generator is actually running a generator returns an iterator. So generators are iterables, and running the generator function returns an iterable. And when you call the method next, it goes inside of the function, and it does not. It runs until the yield and returns an iterator result, wrapping the yielded value. So generators, we see that they are iterables. A fun fact is that they're also iterators themselves, because their method symbol iterator returns this. So they're also iterables. That's cool to know. And iterators they implement the iterable, but they also implement the observer. But I'm not gonna. The iterator is for producing data, and for consuming data, they implement the observer. But it's not really relevant now. So we talked about async functions, iterators, and generators, and now we can talk about the cool new stuff. But no, I'm kidding. I want to talk about streams. A few words about streams. There's a big effort now to standardize web streams. Streams existed, but they weren't accessible to the JavaScript. So Now there will be. I mean, there's a big effort, and it's still in progress. So there are two kinds of streams. There are readable streams and writable streams. I'm going to focus about readable streams. They present a source of data that you can read from, usually an IO source. And chunks are enqueued to the readable streams, and you can read from them one at a time. The consumer can read one at a time and process them, instead of buffering the whole thing into the memory and processing the whole thing in one time. So it reduces memory consumption. Readable streams maintain an internal queue where it keeps track of chunks that were supplied by the underlying source but were not read. So with this queue has a limit, a size limit. So what's cool with the really important thing with readable streams is that they can handle back pressure, and they can handle back pressure. That means that if the consumer is slower, it's processing the chunks slower than the underlying source supplying the data, then it can tell him, send a back pressure signal and tell him, like, do the slow down, so it will wait until there's more space inside of the queue. So the queue has a limit space, and when it reaches it, it will just stop. So did you know that browsers recently added the ability to consume a fetch response stream as a readable, fetch response body as a readable stream? So that's really cool. Chrome already does that. Why not iterate over a readable stream, readable stream? I mean, why not? I want to process the chunks one by one, and I think that's not too much to ask. But this code does not work because the for loop it allows asynchronous determination of the value, but it still requires a synchronous determination of the done state, because every time you get a chunk, it's asynchronously, and you can get the value, it's okay, you can await it, but knowing if there are more chunks, it's also an asynchronous data that you get asynchronously. So we need somehow to support it. So with the new async iteration feature, we actually can do that. With for-await of, it's a new syntax, we can iterate over async iterables. So before we talk about async iteration, let's see what an async iterator is. So async iterator is almost like a normal iterator, but instead of returning an iterator, instead of returning an iterator result, the next function returns a promise to an iterator result. And that's the whole difference. So the next is async. It's a promise. And the async iterable, it has a method with a key of symbol async iterator, which is a different constant. But it's almost the same, all the rest. And as we had generators for creating iterables, we have async generators for creating async iterables. So what an async generator is, it's a generator function that's also an async function. So you can put a keyword async before it. You put an async keyword before it, and you can use the await keyword inside of it. So running an async generator returns an async iterable, an async iterator. So running the method next returns a promise. So what's happening when you call next is that you get inside the generator, and you run until the await, and then it suspends because we are waiting on a promise. So the generator function suspends, and then the execution reverts back to the next method, and it returns a promise. And then when the promise we await on resolves, then the execution continues until the yield and wraps the yielded value with a promise. And that's returned to the next. So it's actually pretty interesting. Every time you call next, it immediately returns with a promise. But the generator is always at one point. So it keeps track who's calling it. So it knows who should get what value. It does it with queues, but I'm not going to get into it because there's not enough time. But it's really interesting. So we saw we can iterate over iterables, and now we can iterate over async iterables. And so we write a for await of and put the async iterable. And what it does a lot of things for us. It takes the async iterator, and awaits on the next, and checks, it puts the result value inside of the result. And if it's done, then it gets out of the loop, and if it's not, then it continues. And you can use it inside any async function. So just so you get a feel of it, I want to do a little demo iterating a response body, because that's really cool. So here I have a huge text file. If you want to read it afterwards, I will send it to you. It's really, really interesting. And I also have a simple HTML file. I have I'm loading a script. Right now it's empty. We will fill it together. And I have two polyfills. I'll explain why I need them when we use them. And now we have this empty file, and we want to iterate over a response body. So that will have to be an async function, because we're doing a fetch with an await. Oh, can you see it?
Yeah.
OK, so we are doing a function. And we will fetch huge dot, see what this response brings to us. So I'm also I will run a server. It's a simple Python server that just serves the whole directory on port 3000. Wait. Oops. Oh, we got a response. I didn't notice. So this is the response, and we see that it's a readable stream. That's exactly what we talked about earlier. It's a readable stream. And it has a locked indication telling us that no one acquired the lock. So no one is reading from it now. So we can acquire it. So now that we saw that, we want to for await chunk of we will want to do that, and console log chunk. But unfortunately, response bodies, like the readable streams, are not async iterable yet. So we'll have to do some work for this. So let's call it stream to async iterable. And let's let's do the function. Let's implement it. What? Oh, sorry. OK, so let's do the function. Stream. And we'll get a stream. And so we saw there are two ways to create async iterables. The first one is to implement the interface, and the second one is to write an async generator. But I think so before we do that, let's see what is actually this response body. Let's see what is this readable stream. So to read the readable stream, we need to call getReader, and it acquires the lock to us, so no one else can read from the stream, because we don't want someone else reading from the stream we are reading from, because they will take some of the chunks, and that's not good. So let's see reader.read. Let's see what it has. So it returns a promise, and this promise is resolved with a done and a value, which is actually an iterator result. So this is really cool, because we can use that, and we can implement the async iterator protocol. We can use it inside of our wait, what am I doing? So we can use we saw that the method next of an async iterator returns a promise to an iterator result. We can use that. So we can return an iterator result, async iterator, like this, async iterator. So it should return an iterator, and the iterator has a method next, and it should return reader.read. So so this is an actually this is an async iterator, because we are returning an async. This is an async iterable because we are returning an async iterator, and it has the method next, and it returns a promise to an iterator result. So this is really cool, because now
change the response body to
well, what? Well,
no, correct. Response body in 12 to a string.
No, response body is a stream.
Yeah, but in line 12 you're getting an argument in a string.
Oh, okay. Thank you. Yeah, live coding sucks. OK, so let's see what happens. And we got the whole thing as streams. And if you're not convinced, they came in chunks. Then now you are probably convinced. So we got raw data, but it was actually a text file. So the cool thing with streams is that you can pipe through a transform stream. So we can use that. So the pipe through, I'm running Chrome 63, and I needed a polyfill for that. It wasn't there, so actually it's 64 now. Pipe through, And I'm going to use a text decoder. So the text decoder actually is an object that has the method decode. So it's not really a transform stream, but I also added a polyfill to make it a transform stream. So now it is for me. So we got text. Yay. Before I forget, I would want to clean after, like if we break in the middle of the loop, we want to release the lock. So I will just implement this little thing, reader dot, and it should return an object. Just I want to see it. I didn't win anything. Yeah, it still works. So this is another way to create async iterables. And that's cool that we can iterate over in a response body. Now we can also update if we have like a progress bar, we can update a progress bar, how many chunks they came. We have the size of every chunk, and we have the content length in the header, so we can use both. We can calculate a progress bar, which is really cool because we couldn't do that before. So we saw that async iteration is really cool. We have a lot more to do with it. Actually, in Node 10, they implemented node streams, which is actually a different stream, kind of stream. It's not like web streams, two different stuff, but they implemented the node streams to be async iterable, and it's experimental now. So with for-await of, we can also iterate over synchronous iterables. And it does the conversion for us. If it sees that if it sees it doesn't have a method with a key of symbol async iterator, it falls back to symbol iterator. So in every value, it wraps with a promise resolve, because the method next should return a promise to an async iterator result. So this is cool because it's nice, because if we had promises that if we iterate over promises, it won't wrap it. It will do this kind of conversion. It will convert it to a promise of an iterator result where the value is the resolved value. And it's nice because for this, in this example, we have an array of promises. And if we just loop on them with for of, we get the promises themselves. But if we want to log the resolved value, we can for await of on them. And we will just get the resolved value. I'm not sure I'm going to use this in production code because, as I showed earlier, in this example, we are running promises concurrently and awaiting on them sequentially, which is it's not so safe. But if we, for example, have a symbol generator that returns promises, that's good because the promises won't run concurrently. They will just run lazily when you get to the point where you yield them, or when you actually run them. If you can have more control. And maybe we're asking yourself, why not await and promise all? So that's something else. If you want to start iterating over values and processing them while they are resolved, like if with a for await of, you start processing the first value after the first promise resolves. And with for await of, you start processing the first value after all of them are resolved. And also with for await of, if one of them rejects, then you don't process anything. The whole thing will reject. So with for await of, you can start processing until one of them is rejected. So here's a list of how you can use them today with async iteration. It exists in TypeScript since 2.3. Bubble has a plugin. It exists in V8. So in Node, it's only you can play with it because it's within Harmony flag in Node 9, and in Chrome 63 it exists, and Firefox has it too. So you can start playing with it at least, and those if you want to play with it in the browser. And that's it. If you have any questions.
Can you maybe give some more examples of how you use this kind of stuff in your day-to-day work? I'm kind of having trouble thinking of day-to-day examples where I would use this kind of stuff. I mean, I use async-await all over the place, but I know it uses generators behind under the hood, but I don't really see why I would go so low level for my day-to-day work.
Okay, good question. When are you going to use it in your day-to-day, right?
Just some examples.
Okay, so we saw the example with the fetch, that we can consume it as a readable stream. But it's not everywhere yet, so it's not really for production, but in a Node it's kind of like getting there. And also you can recreate RxJS. You can have streams of events. You can create a stream of everything that comes asynchronously. Usually it's I/O stuff, like reading from files, fetching stuff, fetching pages. If you want to fetch stuff lazily and not concurrently, and iterate it one by one, it's really suited for that. But streams are really the most. I think it's more for readable streams. It's like the best fit for it because it handles back pressure, and it goes good with a single consumer. And readable streams have a single consumer, so it's really suited for streams. You can think of many kind of streams, not only response body, it can be files and some more stuff. It's not the same as reactive programming because reactive programming is for push streams. And this is more suited for pull streams and single consumers versus potentially multiple consumers. So it's more for stuff like that. Okay, if you have any more questions, you can email me and you can follow me on Twitter. Thank you.